Hey guys, today we are looking at 8.4's note, which is all about graphing quadratics in vertex form. So we looked at standard form in our previous section. Today we're looking at something called vertex form, which I am really a big fan of. It is definitely the most straightforward of the methods to finding our intercepts, or sorry, finding our vertex, as it's called vertex form. Our vertex shows up directly in the format that my equation is written in. So hopping in here to box one. This is what vertex form looks like. So it's a little bit more complicated structure-wise, but it is easier once you get the hang of it, because it's not formatted the way we're used to seeing it with ax squared plus bx plus c. In here, we've got three different pieces of information that show up in our equation. Three letters, in this case, A, H, and K, that'll be replaced with numbers that tell us where our vertex happens, and then whether or not we're adjusting that 135 shortcut we looked at in the previous sections as well. So in here, H and K tell us the X value and the Y value of my vertex. And in this case, you should be careful, because inside my parenthesis here, this is X minus H. So whatever I see in my parenthesis, it's the opposite of the X value for my vertex. So like if it's X minus 2, your X value of your vertex would be positive 2. And in this case, my plus K on the outside, that number just directly as it's written, tells me the Y value for my vertex. Which this table here shows you kind of some different explanations on where those come from, looking at it in terms of transformations, which again we've talked about a little bit, but was more so important in pre-algebra. It'll pop back up again in geometry next year for you guys, or if you're doubled up next year, algebra 2 as well. We do a lot more with transformations, but here what's happening is my graph is just getting shifted around from the origin, because we know in 8.2, when we looked at just the basic quadratic equations, the vertex starts at the origin, and then anything that's happening to my equation now is just shifting my vertex off of the origin, away from 0, 0. So you're not going to have to describe transformations on the test. You'll just be asked to graph the quadratic given the equation. Here today we'll practice just describing it, but for me personally, it's always easier to just plot my vertex based on the fact that H is my X value for the vertex, K is the Y value for my vertex, and then graph the rest of it from there. My A value tells me whether I adjust my 135 shortcut. And this is just the phrasing that we can use to describe those transformations. Again, the most important thing down here is going to be that the vertex is H comma K. And you'll get used to it. As we get through some problems, it'll become easier for you to recognize where that happens. And then the description afterwards is just going to be based on how far it was shifted left, right, up, or down, and whether I stretched it out or whether it's been shrunk down. So let's just hop into box 2. Here we've got a horizontal translation. Our instructions are to graph the function and then compare the graph to the graph of f of x equals x squared. So that's just our parent graph, our original just standard quadratic equation. So if we're looking at comparing the transformations, we're just going to describe it as either being shifted up, down, left, or right, and then whether or not it was reflected or it was a stretch or a shrink. So in this case, if I'm relating it back to what we were just looking at with our H and our K values, I'm having 3 subtracted inside my parenthesis, which tells me my H value is 3. I don't see anything for a K value. I don't see anything added or subtracted after my parenthesis. So that tells me, in this case, my H is 3 and my K is 0. So that tells me my vertex happens at 3, 0. So if this is my vertex, right, V is 3, 0, I can go ahead now and just plot that point. To the right 3, 3, 0. That's my point right there. The A value is always that lead number, the number all the way out in front of my parenthesis, and it behaves the same way it did in 2.3 and in 2.2, where that A value just adjusts the 135 shortcut that we looked at in 8.2 if we do have an A value. Now here I don't see anything, so we know it's a little imaginary 1, which means I'm not adjusting the 135 shortcut at all. I just follow the regular shortcut. For my vertex, I go up 1 over 1 on both sides. I go up 1, 2, 3 over 1 on both sides. And then up 1, 2, 3, 4, 5 over 1 on both sides since it fits. connect my graph with a nice smooth curve, and I'm good to go. Now again, you only need to do 5 points at the minimum. I did 7 here just because it all fit on my graph. But the bare minimum for graphing it, you should have your vertex, 2 on the left, 2 on the right. So now that we have this one graphed, finishing up this problem, we have to compare it to the graph of the original one, which, again, my original function is just x squared. That's the very first one we did back in 8.2. If we need reminding of that, I can do that in red here, but our original one, vertex is at 0, 0, and then the regular 1, 2, 3, 5, shortcut. So if we take a look at comparing my original red graph to the one that's been transformed in blue, the only thing that's happened is that it was shifted to the right 3. So there's a lot of different ways that you can phrase that. You can say it's a horizontal translation 3 units to the right. I don't have to be anything, I'm not requiring anything that fancy if you have any of these questions. Just telling me what kind of transformation it is. So it's a shift. Tell me which direction to the right, and then by how many? 3. All right, so heading over here to box 3. Box 3's instructions are a little bit different. We're asked now to still graph the function, but then they want us to identify the vertex and the AOS. So I'm actually going to start with that part, identifying my vertex and my AOS first, because right above here we can see kind of where those things come from. That is more likely of a question that you're going to be asked on the test for chapter 8. Once you have the equations graphed, identifying the vertex and the AOS is a pretty standard follow-up question if I have anything beyond just graph the function. So this is a combination now. You can see we've got numbers in there for my A, my H, and my K. So my H and K values, again, are always H is on the inside, K is on the outside afterwards. So my vertex is always H comma K. Now here, a little bit confusing, or I guess a little bit more tricky, because I see my parenthesis as x plus 5, and in my formula up above, it's always x minus h. So in this case, I would have to call my h negative 5, because negative 5 is what would have to be subtracted from x to make it look like x plus 5. So a little bit weird, but again, inside your parenthesis is always opposite of what you see. So in this case, x plus 5 is what I see in my parenthesis, so my h value is negative 5. My k value always matches exactly, so since I see minus 7 after my parenthesis, my k value is still negative 7. So there's my vertex. My AOS, remember that is always x equals the x value of vertex, so in this case that's h, which would be negative 5. Which, again, those formulas are up above there. You'll have the cheat sheet for this chapter. We'll have, not the table, I don't think. I'd have to check and see for sure. But it'll have the equation and then the stuff down below where it says vertex is h comma k, AOS is x equals h. Okay, so now that we have those described, we can go ahead and plot them. Negative 5, negative 7 is my vertex, so that's left 5 down 7 right there. My AOS I can do in red. There we go. Vertical line through there. Now this one does have an A value in there. I have a positive 2 out in front of my parenthesis, so that tells me my 135 shortcut is going to be doubled, right? Because that A value is always multiplying my 135 shortcut. So 135 is going to get doubled, so times 2. So instead of 135, I'm going to go 2, 6, and 10. And again, we want to try and at least get the first 2 points on each side on there. So from my vertex, I can go up 2 over 1 on both sides. And then from there, I'm going to go up 6 over 1. My next one would be up 10 over 1, which is just going to be barely off my graph. There we go. And then just connect my dots with a nice smooth curve. So I'm going to go ahead and... a little bit ugly on that right side, but that's okay. As long as I can see that you're making an attempt at being curved, and we're always going to the right or going to the left. We don't curve back inside. You can see my right side kind of does that accidentally, but you would be fine. I would not take any points off for that. All right, last one, box 4. So same exact instructions. Graph the function, identify the vertex in the AOS. So once again, here is my H, here is my K. So my vertex is always H comma K. We're back to it looking like subtraction, which means my H value is now going to be a positive 3. Because 3 is what was subtracted from X in my formula. And then positive 4 is my K value because it was plus 4. So there's my vertex. My AOS is always just X equals the X value of my vertex. So I can go ahead to my graph. 3, 4 is my vertex. My AOS goes through it. So there's that one. Now this one, extra tricky because my A value is not only a fraction, it's a half, which means my graph is going to get shorter than it usually is. It's also negative, so that means my graph is going to be a frowny face instead of a happy face. Right? It's going to be a downward facing parabola rather than an upward facing one. So if you need to, again, off to the side, you can do your 1, 3, 5 shortcut and multiply those by your A value. So negative 1/2 times 1 is negative 1/2. Negative 1/2 times 3 is negative 1.5, and 5 times negative 1/2 is negative 2.5. So instead of up 1 over 1, up 3 over 1, up 5 over 1, I'm going to go down 1/2 over 1, down 1.5 over 1, down 2.5 and over 1. So down 1/2 over 1 would be right there and there. Down 1.5 over 1 would be here and here. So those are nice coordinate points, 1, 2, and 5, 2. And then down 2.5 over 1, down 2.5 over 1 would be 0, negative 1/2, and then 6, negative 1/2. We could keep going if you really wanted to, but we call it the 1, 3, 5 shortcut because really those 7 points are plenty for us to get an idea for the shape of my graph. All right, well, that's it for vertex form. Your homework, which is down there at the bottom, is page 446, 20 through 44, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, we'll see you soon.